Good morning, Paragon Mills family. This is Miss Clark, one of your third grade teachers, here to help you with the math in our April 20th packet here on Tuesday. So let's start with a number talk, just like we would every day in class. So we have this wonderful picture right here. And the question that I'm going to ask you is to write a multiplication equation to represent the number of glass doors in the picture. Now, to be clear, a glass door is 1. So these two doors, this is a sliding glass door, and it counts as 1 glass door for our problem here. All right, so I'm going to give you about 30 seconds of wait time to come up with a multiplication problem to figure out how many glass doors are in the picture. I don't want you to count them. I want you to write a multiplication equation. So something times something equals the total number of doors here. All right, pause the video below so that you can work on your multiplication problem. Did you pause the video? Good. Okay, so let's talk about what our multiplication problem would be for this picture. There's a couple of options on how you could write this. So let's talk about it. What is one way we could write a multiplication problem? Well, I noticed that there are 4 doors going across. So I guess 4 could be one of my numbers. So I'm going to write one of my multiplication sentences right down here. So I have 4 times, right? Okay, so now let's see if we can figure out the other number in our multiplication equation. So let me count down the side here. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm saying that my multiplication equation is going to be 4 times 8. Now, does this multiplication equation describe our picture? Yes, it does. Okay, awesome. So, because we have 4 windows going across and 8 windows going down. So what is the total number of glass doors? Well, I'm going to skip count it so I can figure it out. 4, 8, 12, 16, 20, 24, 28, 32. So after that, 4 times 8 is 32. Okay? That is one way we could have written our multiplication equation. But is there another way? Let me think. I know. Because when I learned my multiplication, I learned that I could switch the order of these two factors, but my answer would still be the same. So let's try that. If I go 8 times 4 equals 32. Can I do that? I should be able to. Let's skip count and see. So I have 8, 16, 24, 32. Did I get the same answer? I did. Okay, so we're saying that our multiplication problem for this picture is either 4 times 8 equals 32 or 8 times 4 equals 32. Very good job, you guys. I'm so proud of you. Really been keeping on track with your multiplication tables. All right, so now we're going to discuss this lovely math problem that was given to you, this task. Okay, you've probably looked at this and been like, what? I'm all confused. Well, don't worry, because I'm going to help you break it down and help you make some sense of it. So first things first, let's talk about what we're going to be doing here. We're going to work with knowing and applying area and perimeter formulas for rectangles in real-world math. Now you may be looking at this and going, how is this real-world math, Miss Clark? There's nothing here I'll use in the future. But you want to know something? There actually is a lot of real-world math in this problem, because real-world math is math we use in our jobs. So let's talk about an architect. An architect is a person who designs buildings and spaces and lays things out for us so that we know if something's going to fit. They design things for us. So you're being asked to design or create a museum layout for these 4 lovely exhibits. So let's talk briefly what each of these are. A tropical rainforest. Does anybody know what a tropical rainforest is? A tropical rainforest is a really lush, green, beautiful space. It's absolutely gorgeous. There's a really good picture here. It's just beautiful, okay? All right, so that is a tropical rainforest. Then we have the polar ice caps. And those look like this. The picture got small on you. Polar ice caps. There are lots and lots of ice there. Okay? Those are polar ice caps. All right, and the third one was an arid desert. Now, an arid desert is just what it sounds like. It's really, really dry. It's hot. It's not fun. There's very little water. Nobody wants to be there if they can avoid it. And then we have the temperate forest. And that is your much more traditional forest picture. See, it's trees and grass. The sun is shining through. It's nice. It's green. It's pretty. That's your temperate forest. Okay. Now that we've gone through and we know what all of our exhibits are going to look like, let's talk about this problem. So, first things first, it says you are designing the floor plan of a climate museum. So a climate museum is simply a museum that's going to explain those 4 habitats or exhibits we talked about, right? We've talked about habitats before. They're different places and homes for animals, right? So each rectangular exhibit, so we know that these all have to be shaped as rectangles. We can't draw triangles. We can't draw crazy lines every which way. Will represent a different climate. So you will have one rectangle that represents the tropical rainforest. And, oh, look, it already told us how big the area is. Wonder if that'll be important here. Probably will be. All right, you will make 2 floor plans for your museum. Here are our exhibits, and here's the space requirements they have. So our tropical rainforest will require 12 square units. Our polar ice caps will require 6 square units. Our arid desert will require 10 square units. And our temperate forest will require 16 square units. So we also have some other rules here. None of our exhibits can touch the walls of our floor, and none of the exhibits can touch each other. Okay? So we have to think about how we're going to lay this out. So we get all of these spaces in without touching any walls and without touching each other. So I can't have the tropical rainforest touching the polar ice caps. Does that make sense? Okay, so we gotta complete this exhibit measurement form first. Okay? So, we're going to complete this, and this is going to be your assignment today to finish up, okay? But we're just going to kind of talk through it. Okay, so we already know the total area of each of our exhibits, and they've listed those for us. And to get area, you guys remember our area formula? We've talked about it several times in school. Our area formula is always length times width. So let's just talk through this chart. For my tropical rainforest, I don't know the length and I don't know the width. And I don't know what these numbers are. But I do know the total. If I know the total, can I figure out what my lengths are? You sure can. All right, so I'm going to do the first one with you. Okay, and then you're going to complete the rest of this chart on your own. If you don't have the chart in front of you, that's okay. You can go to mnps.org/printables and go to the grades 3-4 band, and you will find the printable for April 20th that week, and this math problem will be in there, okay? Or if you don't have access to a printer, you can just write it down on a piece of paper. All right? Okay, so let's look at our tropical rainforest. I know my total area is 12. So that means something times something equals 12. Let's think back to our multiplication facts. What do I know equals 12 when I do my multiplication facts? Well, I know 1 times 12. That one's pretty easy. But do we really want one long rectangle? That'd be kind of hard. What else could equal 12? Well, there's always 2 times 6. 2 times 6 equals 12, right? Okay, so that's what we're going to write. We're going to say two times 6. Now, one of these numbers represents the length, and one of these numbers represents the width, okay? So when I fill in the chart, I will have a length of 2 units and a width of 6 units. So that means that I will have 2 units and 6 units, and 2 units times 6 units is 12 square units. Okay? So you're going to finish up this chart, but before we do that, let's talk through this sentence stem here at the bottom. Okay? All right, it says, to find the blank of a blank, you can multiply its blank by its width. Okay, so what do you think if we're multiplying something, are we finding the total of something or are we finding just a piece of it? Why don't you tell a parent or a sibling that what we're finding? Okay, so we're finding the total. Very good. Okay, so you're going to find the total of something. So if I'm trying to find the total, what is that called? It is that's right, we're looking for the area. Okay, so I'm going to write that. So to find the area, okay, to find the area of a blank, what shape do we typically find the area of? I know I typically find areas in rectangles when we're doing this at school. So I'm going to guess that it's probably a rectangle. Okay, to find the area, you multiply its blank by its width. Oh, I know this because it's already in my chart. I multiply its length by its width. So this blank here is length. Okay, very good. Now, to find the length of a rectangle, you can divide its area by its, oh, this is the other part. I already have length, so what's the missing one? I need width. Very good. Okay, so let's read it one more time. To find the area of a rectangle, you can multiply its length by its width. To find the length of a rectangle, you can divide its area by its width. Okay? All right, guys. So you're going to finish the chart, and on Thursday when we come back to this problem, we're going to go over it. All right? All right, guys. Have a great day. I love you guys. I miss you, and I can't wait to see you guys.